hate
All
those
right.
pulley things. I've never in my life. I understand them well. They're... All right. So when we finished up yesterday, no, because y'all didn't come to school on Sunday. When you finished up on Friday, we looked at position. We looked at velocity. Did we look at acceleration?
Yes.
No, we really didn't. We didn't draw graphs of it though, right?
Oh.
All right, but for position, all right, position is represented with a what?
With
Letter.
a delta.
Okay, delta what?
Is it delta x?
It is delta x. All right, velocity, letter,
Delta v.
acceleration,
That's just an a.
that's just an A. All right, it's special. So it doesn't matter.
That's
But no, I mean, it's so special that it's always a vector.
right, but that's
Okay, because of my handwriting. I'm with you. All right. How are position in our graphs, how are position and velocity related? We said that velocity was the what of position?
scalar. No, vector. Correct.
Okay, it is a vector, always a vector for our velocity, because it's not speed. But remember when we used our hands, what were we figuring out?
The slope.
The slope. So velocity is the slope of position. Does anyone want to take a guess at what acceleration is? So if velocity is the slope of position, acceleration is the
Slope of velocity?
slope of velocity. All right, someone tell me, when I draw my graphs, how do I draw them?
Like that.
Like this, right? Where do my arrows go?
The top.
Up and to the side.
Yes.
Why don't pretty arrows go over here?
Because we don't cross.
It is irrelevant. Why is it irrelevant?
Because Mrs. Miko's graphs only go that way.
Because they only go that way. Can we have negative time in our world?
No!
All right. Now, this portion of my graph is what?
It's positive.
This is my,
Origin.
this is my.
Negative.
All right, so I got my x graph. This is my v graph. And this is going to be our new acceleration graph. So we get to learn something new. All right, who wants to be brave and try the position graph? You're starting to the right of the origin, moving left, crossing the origin. Who wants to be brave? Josh is going to be brave. Do you want it blue? Okay. Remember, just write on it. So, you're going to start right at the origin, moving towards the left, crossing the origin.
That seems like I've seen one,
Well, it basically, you're moving left.
but I can't.
Right, so what do we do? Where do we start? Where does it tell you right of the origin? And right is our what type of position? Good. All right, so it's positive. So start somewhere, I would say start higher up. Yeah. All right, and we're crossing the origin. Okay. And we're moving left. All right, now let's take a look at this. Out of the graphs we drew last class, does this look like one of them?
No.
It's pretty. But what did our lines look like? Do you mind if I erase?
Oh.
Oh, you got it. All right. Back there. It's like a workout. Okay. So. Oh, that's an awesome line. Okay. So we've started positive, right? Right at the origin. We've crossed the origin. Now we're into our negative territory. All right, so this. Who wants to be brave and try velocity? Velocity is our slope. But what do we know? When velocity is when position is a linear line, it's a straight line like this. What does our velocity graph look like? Is it? When all our position is just this single thing. Someone tell me, what is the slope of that line?
It's negative.
It's negative. What does my velocity graph look like?
It's
Yeah, negative.
Okay, it's going to be negative. And who remembers Z the turtle?
It's going to be a straight line.
It's going to be a straight line. So, Shelby, you want want to come draw me a straight line in my negative sphere?
Yay.
Alright. So which part of my graph is negative? Show me the portion. And it's a flat line, right?
Like on there or like?
Well, okay, here's my question. You told me this slope was what? When you put your hand up, it was negative. If you drew it up here, it would be what? If you drew it here, you would have, what is this? This is our zero. If you draw it down here, it'll be what? All right. But what did you say it was? You said it was a flat line.
Oh, that means
But where have you drawn that line? Talk it out. Over there.
Yeah, I'm just gonna redraw that.
That's fine. Hey, it's just fun playing with the board.
Yay.
Oh no, we didn't hit pen hard enough. It's okay. Don't worry about the pink. It's okay.
That's a messed up graph. That's gonna bother me. Okay.
All right. So we know that we need a flat line in our negative portion, right? So draw us a flat line in our negative portion. Yep. Yeah. Because what did y'all say the slope of this line was?
That was negative.
It is negative. We put our hand up there, we see that it looks negative, so we have a negative slope. Now, so our negative slope gave us a negative flat line. Someone tell me what the slope of this flat line is. So if I come over to my acceleration graph, what's my acceleration?
Positive.
All right, take a look. We said the slope of this line is 0. All right, and remember, accelerations are slope of velocity.
Oh,
So what's our answer?
0.
We have no acceleration.
Not
So here's a question. Is this an example of a ball being thrown up in the air and coming down?
No,
No. Why is it not, Cody?
because gravity works, well, yeah, because gravity works.
Because gravity works.
When you
Is my
got,
pin going to drop?
yes.
Yes.
At the top of its arc, is my pin going to drop?
Yes.
And when it comes on this side of my arc, is my pin going to drop?
Yes.
Yes. So obviously, this is not a ball or a pin being thrown up in the air.
That is a car moving constantly at like 15 miles per hour.
All right, yep, its velocity is maintaining. We're not accelerating. So we are not passing the slow person in front of us. We are just cruising on a Sunday drive.
Yes.
And what's nice is, remember, I get to send this to y'all. These are your notes for the day. Yes. I'm going to tell your parents that this was your handwriting. Just kidding. All right. A ball accelerating. Now we have a ball in a hill. All right. Now, this is where it gets kind of tricky. It does say the ball accelerates down the hill.
To the right.
There you go, Josh, to the right. And what is that position?
Positive.
Okay. It's going to roll across a flat plane. So if you can try to visualize this in your mind, we have down the hill to the right. It's rolling, it's rolling. And then it's going to go down another hill, but in what position?
It's flat.
All right, so it's flat there. It accelerates down another hill to the right. So it's what?
It's positive.
All right. When it is rolling, all right, let us hold on to our flat plane for a moment. Since we're good at velocity, we're going to do our velocity graph first. This portion of my graph is,
Oh, that person is the y-axis, which is velocity, which, yeah.
but this portion,
Oh, it's negative, that's,
this portion,
that area back up,
right,
negative,
up here,
there, positive.
there you go. Up is always positive, right?
Yes.
This is my,
Origin,
which is,
0.
0.
and this is my what portion?
Negative.
All right, I'm rolling to the right. Am I rolling in a positive manner or a negative manner?
You're rolling in a positive.
All right. So I'm accelerating to the right and I'm going velocity. Now, would you agree, or how many sections should I separate my graph into? Let me ask that first.
Probably 3.
There you go, Josh, 3. So I like to go ahead and draw my dotted lines in so that I know where I'm going to be drawing. All right. We're going to roll to the right, cross a flat plane, and accelerate another hill to the right. All right, for velocity, where do you want to start?
Well, even though it's positive on velocity,
Shouldn't we
you get
start at the origin?
Should we?
No.
Where do we think our origin in this case is going to be?
Top of the hill.
The top?
What says here? Well, do we really know where the ball is? Because it simply says it's rolling down the hill.
Right.
It's out
We
of
don't really
course.
know. But if we look at these two portions, which of these is our neutral portion?
Looks like.
The flat plane. So let's start at our flat plane. Would we agree that the flat plane would be at 0?
Yes. Some of the hill.
It's not. Or it's rolling, but it's constant,
no,
right?
it's not.
All right. Now, we have to figure out how is our ball rolling.
Well, it's went down, but it's going to the right.
It's rolling down, but to the right.
It's
Okay.
rolling negatively.
All right. So it's going to start negative, right?
Yes.
And sort of, now, if we're a ball and we're rolling down, we're getting faster, we're getting slower.
You're getting faster.
We're getting faster, right? So, we are getting faster in this portion. All right, so we're a ball, we are getting faster. Does that make sense? All right,
Yes.
but then, when we're sort of rolling along at our constant speed, are we getting much faster?
No.
But, oh, here's another hill that I'm falling down to the right. So, what happens in my last portion?
So you're getting faster.
We're getting faster. So, our ball speeds up, moves along at a constant, and speeds up again.
Wait, when it's going at a constant, it's losing momentum, so it's going to be slowing down.
Okay, I would have normally said that. It slows down as it rolls across a plane. You can try to think of this as a frictionless surface. Yeah, yeah. You have to pretend. Now let's try our acceleration graph. Still have 3 portions.
Ooh.
There we go. Get back. All right, 3 portions. My slope here is what?
Positive.
Positive.
Yes.
So, positive slope. Where do I draw my first line?
Up.
Up.
All right. What's this slope?
0.
Nothing.
Nothing.
Do we agree it's here?
Yes.
All right. What's the slope of this?
Positive.
Positive.
Not more positive.
All right. And yeah, we don't have to be too exact. We have a positive, a 0, and a positive. Now, let's see if that makes sense. If we are rolling down a hill, are we speeding up or slowing down?
Speeding up.
I have positive here, right?
Yep.
I'm getting positive. Does that make sense? Positive, positive, speeding up?
Yes. Yes.
All right. Let's not worry about our flat plane. Let's just keep on going. I found another hill. I'm positive. This is positive. What am I doing?
You're speeding up.
No.
Speeding up. So do our graphs make sense
Yes.
for what we're doing? That's always a plus. I keep thinking I need to hit that to move. Okay, a bowl roll. Wow. A bowl? No, it's not a bowl.
A ball.
A ball rolls up a ramp to the left and then rolls back down the ramp. This is probably the trickiest question that you'll see. Right? Here's what I want you to look at.
It is tricky.
A ball rolls up the ramp to the,
Left.
which is,
Negative.
do we agree?
Yes.
And then rolls back down the ramp to the right, which is
Positive.
positive. I didn't write to the right because I assumed you can imagine. Okay. Now, but I give you all 3 graphs here. Okay, that works. Now, acceleration. I don't know why I put them in this order. I like to start in position and work my way over. But okay. Now, this time, all right, here's my ramp. My ball starts here. Do we want to make that the what?
Order.
Does that make sense?
Yes.
To make it the origin? Because that's where we're starting and that's where it ultimately ends up. Makes things easier. All right. Now, so I'm going to start here with the position graph. And I'm going to, I can't erase with my finger. No, I don't need to make 2 parts. All right. We start at the origin. What does this graph look like?
Looks like a triangle.
Okay. Kind of. However, I'm with you on the triangle bit. I understand what you're talking about.
I just see 2 lines, I see that.
Oh, no, but he was taking a guess. It does go up. Do we agree that it goes up?
Yes, let's do some.
Okay. And then, what does it do?
It goes down.
It comes back down. Now, here's your question. Has motion occurred?
No.
We started and ended in the same spot, right?
Yeah.
At the origin. That's one of your magic physics questions.
It's a hump.
All right. Does anybody know what this shape is?
Is it a hump?
It is a hump, but it is also known as a parabola.
Ooh.
Ooh, it's upside down. It can be this way. It can be upside down. All right. Parabolas. Now, last time we only dealt with position graphs that were linear, correct? All right. And when we had a linear graph, position graph, what did my velocity graph look like?
It went down. It came up from down. Then it went.
What did that velocity? Okay. Here,
Oh.
how about tell me this? What is the slope of this line?
It's negative.
Negative.
Negative. What would my line look like for my velocity graph? It would be negative, but what would it look like? Would it be linear or a flat line? Flat line. You can't have 2 linear graphs. This one's got to be different. So this one would be our flat line.
Is that because there was no motion?
It has more to do with the slope of the line.
But even though it's negative, it's flat?
Yeah. Yeah, it doesn't matter. Remember, a linear graph, position graph, always gives us a flat line velocity. And someone tell me what the slope of this line is.
0.
0. So it gives me 0 acceleration. Okay? I'm not going to spell it out because I don't have one. All right. So, linear position gives me what type of velocity?
Negative.
Okay. Try not to think of the direction. Tell me what it looks like.
Flat.
Flat line, which gives me what type of acceleration?
None.
Good. Linear position, flat line velocity, 0 acceleration. All right. Now, does anybody remember what happens when position was a flat line?
It just means it didn't move.
Okay. But what's the slope of this line?
Nothing.
So velocity is 0, correct? Now we have a parabola. A parabola. Does anyone want to take a guess at what our velocity line could look like? Now, here's your choices. Your choices are linear or flat.
Flat.
Take a look. If a linear line gives you flat, can a parabola give you flat?
Yes.
No.
No, we can't double up. It would be nice. But in this class, no, we're not doubling up. So look, flat line gives us a 0. Linear gives us a flat line. What do we think a parabola will give us? And your choices are flat line or linear. It is linear. All right? So the graphs always look the same. Now, with my ball rolling up, it's rolling, 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 right? It's rolling up. All right, and it's rolling to the left. Do we agree?
Yep.
It's rolling to the left. So, someone tell me if it's rolling to the left, the velocity is what?
Negative.
Good. Okay, velocity negative. Now, anyone want to take a guess at what the velocity is at the top of the ramp? Think of it like when you throw something in the air and catch it. 0. Good. Is that what you said? Good. 0 velocity up here. Now, if my ball is coming down and moving to the right, my velocity is what? Positive. Positive. Positive velocity. So, our velocity starts where?
Negative.
You got it. Moves to
0.
and becomes. All right, and our line has to be linear, correct? So, this is my positive end, this is my negative end. Where do I start my pen? Say it louder.
Negative.
At the negative. Move up to.
Positive.
Yes, but through what?
The origin.
And then get positive, yes? So my parabola has given me a linear line. All right? Now, linear lines always give us a what? Linear lines always give us a slope, and the slope of it looks like a what? Flat line. Now, we have to decide where our flat line goes. What's the slope of this line?
Positive.
So, do I draw my flat line up here or down here?
At the bottom.
Okay, what did you tell me the slope was?
Positive, be at the top.
It'd be at the top. Now, let's see if that makes sense. Ball is rolling up. I've got negative velocity. Now, when that ball rolls up that ramp, is it going faster or slower?
Slower.
So, what if my velocity is negative, what does my acceleration have to be?
Positive.
Negative.
Negative.
All right, okay. Let's stop. We got
0!
All right. Y'all know the cheer. Don't make me make you stand up and do it. All right. It's rolling up. Y'all said it's doing what? When things roll up, it slows down.
So it's
So if my velocity is negative, what does my acceleration have to be?
positive.
Positive. Is this my slow down motion?
Yes.
All right. Now, all right, we're coming back down. All right. My velocity is now what? When I come down, I got what type of velocity? Positive. When you come down a ramp, are you going faster or slower?
Faster.
So, what direction does my acceleration have to be in to go faster?
Same.
Same.
The same, so it has to be
Positive.
Positive.
positive. All right, that's how we do our cheer to help us remember if we're doing it right. All right, so, and I have a nice positive line. So, on the next part, I'm not going to be super mean.
Velocity is always negative. I mean, not velocity,
Yeah.
acceleration is always negative.
Are we tossing the ball up in there and throwing it back? And catching it? When we throw balls? Yes. All right. I'm going to draw a position graph. When you feel brave, velocity, acceleration. All right? I'm drawing 3 different graphs.
Oh,
Yeah.
that looks like
This is the flat line. This is a linear line. Oh, I don't have room. This is a parabola. Oh no, let's do the other way. I just did that one. Parabola. So 3 different graphs. And when you feel brave.